In a servo-hydraulic system, a single-rod cylinder extends faster than it retracts. This may seem wrong, because if the supply flow is the same, retracting should be faster since there is less volume on the rod side. The formula velocity equals flow divided by area says that for the same flow, the smaller the piston area becomes, the faster the cylinder should go. When retracting, the area on the rod side is less, so it should go faster. This is indeed true for hydraulic systems where the supply flow is limited. In a servo-hydraulic system, it's different. The hydraulic power unit is designed to provide constant pressure to the valve and is sized for more flow than the motion requires. To see what is happening, we look at the pressures, forces, and flows. As the cylinder extends, there is a pressure drop in the valve from the supply pressure to the A side of the cylinder and another pressure drop from the B side of the cylinder to tank. As the cylinder retracts, it's the opposite. There is a pressure drop in the valve from the supply pressure to the B side of the cylinder and another pressure drop in the valve from the A side of the cylinder to tank. Why are pressure drops important? They tell us how much flow will happen. The pressure drop is related to flow according to the formula. Pressure drop equals flow divided by the valve constant squared. This means that a small flow creates a small pressure drop, and a large flow creates a much larger pressure drop. As the cylinder extends at a constant velocity, there is a flow from supply pressure to the A side of the cylinder with a corresponding pressure drop and resulting A side pressure. The large A side area means there is a large pushing force available on the A side of the piston. On the B side, because the piston area is smaller, there is a smaller flow. This flow creates a pressure drop as it flows through the valve to tank. This pressure drop results in a B side pressure, giving a resistive force that opposes the pushing force on the A side. Similarly, as the cylinder retracts, there is a flow from supply pressure to the B side of the cylinder with a corresponding pressure drop and a resulting B pressure. The available pushing force on the B side of the piston is smaller this time because the area is smaller. This smaller force pushes the A side oil through the valve. Because the A side piston area is larger, the A side flow is larger, making the pressure drop much larger, creating a larger available resistive force, although the actual force at constant velocity will equal the B force. So, when extending, the large A force is pushing the small B volume of oil through a small pressure drop in the valve. When retracting, the small B force is pushing the large volume of A oil through a large pressure drop in the valve. This difference in forces and pressure drops is why the cylinder extends faster than it retracts. For more details, including formulas and a mathematical proof, see Delta's other videos.